Till now, we have discussed about symmetry and number of lines of symmetry for a circle, for a rectangle, for a square, for a rhombus. This video tutorial is about symmetry and number of lines of symmetry of a triangle. Now, you know that a triangle can be, an equilateral, can be a scalene, can be an isosceles triangle. Now, depending upon whether a triangle is an equilateral triangle or an isosceles triangle or a scalene triangle, its symmetry will depend on those factors. Okay, it will depend whether a triangle is equilateral, isosceles, or scalene. Now, first discuss about an equilateral triangle, that is symmetry of an equilateral triangle. Now we have this equilateral triangle here, ABC. In an equilateral triangle, we know all the sides of the triangle are equal and all the internal angles are equal. Angle A is equal to angle B is equal to angle C. This line segment AB, that is this edge AB, is equal to edge AC is equal to edge BC. That's why if you pass a line, something like this, from this vertex in a way that it passes from the midpoint of the opposite edge of this vertex, then again a vertex, a midpoint of an edge, a line passing through the vertex and connecting the midpoint of the opposite edge, this will be the line of symmetry. Why? Because this will divide this triangle into two equal halves in a way that each half is a mirror image of each other. And how? Just imagine that this is the mirror line or the line of symmetry or the axis of symmetry for this triangle, and you have placed a mirror on this mirror line. Now if you try to view this left portion of this left divided portion into the mirror, then the mirror image that will be formed will be exactly similar to this right one. The right one will appear as the image of this left portion. In the same way, if you try to look this right portion into the mirror, then the image formed will be exactly similar to this left portion. That is, the left portion will appear as the mirror image of this right portion. It means that you can look this discussion in another way, that if this is the folding line of this triangle, and if you try to fold this triangle, either both these sides, the divided sides, or any one of the divided sides, if you try to fold them around this folding line, then you'll get something like this. What these dotted lines are showing is that you have folded this right portion, divided portion, around this mirror line, and when you fold it and you'll bring towards this left portion, then this vertex will exactly overlap with this vertex, that is B. This line will exactly come over or overlap with this one, and this line segment, that is a divided line segment, will exactly come on this one. And all these things, all these three, whatever we have discussed, that is overlapping, will exactly come like this, and it has been represented by these dotted lines. That means it is a perfect mirror image. It is a mirror image. There was no need to add that adjective perfect. So it is a mirror image. That's why this L1 is a line of symmetry. It's one of the line of symmetry. And why one of the lines of symmetry? Because there are more than one lines of symmetry in an equilateral triangle. I'm just going to show you in a while. So we have got one line of symmetry in this case, that is L1. If I do similar thing with this vertex, a midpoint of the opposite edge of this vertex, and if you pass a line that will cross this vertex and the midpoint, it will exactly divide this triangle into two equal halves in a similar way that we just discussed earlier, right now. So you'll get something like this. That is, if you try to fold this this portion around this folding line, that is a mirror line, and if you fold it and it will bring it upon this section, then it will exactly overlap on this one. That is, this vertex C will fall exactly on this vertex A, that is, it will overlap with this one. This edge will exactly come over this one, and this divided line segment will exactly overlap with this one, and all these things have been shown by these dotted lines. That is, this half and this half are exactly mirror images of each other. Okay, that means L2 is also a line of symmetry for this one. If you do similar thing for this one, then you'll get something like this. That is a vertex, the opposite edge of this vertex, the midpoint of this edge, this vertex, a line passing from the vertex and the midpoint, will divide the triangle into two equal halves such that each half is a mirror image of each other. Then if another way to look this discussion would be that if you try to fold this section around this mirror line, and if you try to bring it upon this section, then it will exactly overlap with this section. That is, this vertex A will exactly overlap with the vertex B. This divided line segment will exactly overlap on this one, and this edge, that is AC, will exactly overlap on this one. And why all these things are happening? Because in an equilateral triangle, all the edges are equal and all the internal angles are equal. That's why you are getting these three different lines of symmetry. So, what all lines of symmetry have we got in case of an equilateral triangle? We have got this one, we have got this one, and we have got this one. Now you can exactly see they are passing from a common point, right? They are intersecting at a common point, all these three. Now L1, L2, L3 are the three lines of symmetry of an equilateral triangle. Therefore, if it is given to you that a triangle has three lines of symmetry, then instantly you can tell that that triangle is an equilateral triangle. A triangle having three lines of symmetry, it means that that triangle is an equilateral triangle. An equilateral triangle will have three lines of symmetry. Okay, so this was about an equilateral triangle. What about an isosceles triangle? What about an isosceles triangle? So we have this isosceles triangle here, and this is vertex A, B, and this is vertex C. Now, in this isosceles triangle, this edge AB is equal to edge AC, and that is the definition of an isosceles triangle, that an isosceles triangle is a triangle in which two of the edges or the sides are equal, and since two of the edges or the sides of an isosceles triangle are equal, therefore these two internal angles, that is the angles made by the two equal edges on the third edge, will also be equal. That is, angle ABC will be equal to angle ACP. This is a basic definition of an isosceles triangle, and we already have discussed all these things when we were learning geometry. Therefore, if we pass a line from this vertex that exactly passes from the midpoint of this opposite edge to this vertex, then this triangle will be divided into two equal halves in a way that each half is a mirror image of each other. That is, if you try to place a mirror on this mirror line, or the line of symmetry, or the axis of symmetry, then if you try to look this section into the mirror, then the image that will be formed will be exactly similar to this section. That is, it will appear that this left section is the mirror image of the right section, and the right section will appear as the mirror image of the left section. Therefore, this is an angle of line of symmetry, and you'll get something like this. That is, if you try to fold this section, that is the right section, and try to bring it after folding on this left section, then the vertex C will exactly come over B, and this edge will exactly come over AB, that is, it will overlap, and this divided line segment will exactly come over this divided segment, that making them a mirror image of each other. Therefore, this is a line of symmetry. Now, can we have another line of symmetry as we saw in the case of an equilateral triangle? No. And the reason is that in an equilateral triangle, all the three sides were equal. And that makes that all the three internal angles were equal to each other. But in this case, we have only these two sides that are equal in an isosceles triangle. And only these two angles are equal. Therefore, you can have only one line of symmetry. And we can't have a line of symmetry that will pass from this vertex P and from some point from here. Because in that case, you are not going to get the two equal halves that are mirror image of each other. And the reason is that only these two sides are equal. Okay, so therefore you can only get line of symmetry around this vertex. Okay, that is, the line should pass from the common vertex of the two equal sides. Same thing from here. If you pass a vertex from here, passing from the midpoint of this line, you're not going to get two equal halves that are mirror image of each other. Okay, so in the case of an equilateral triangle, you will have three lines of symmetry, but in the case of an isosceles triangle, you will have only one line of symmetry. Therefore, if it is given to you that you have a triangle which has only one line of symmetry, then instantly think of an isosceles triangle. Okay, so we are done with equilateral triangle of isosceles triangle. But what about a scalene triangle or a scalene triangle? This is a scalene triangle. A scalene triangle means that none of the edges are equal to each other, and it means that none of the angles, that is angle A is not equal to angle B is not equal to angle C. No, none of the edges are equal, none of the angles are equal. It means that you are not going to get any line of symmetry in this case, because none of the edges are equal, not a single, no two angles are equal, making this triangle not symmetrical. Okay, therefore you're not going to get any line of symmetry in this case. So if it is told to you that you have a triangle which has no line of symmetry, then you will instantly say that it is a scalene triangle. Okay, so no line of symmetry in a triangle means that triangle is a scalene triangle. Only one line of symmetry, it means that that triangle is an isosceles triangle. And three lines of symmetry, it means that that is an equilateral triangle. So no line of symmetry, one line of symmetry, and three lines of symmetry. But wait, no line of symmetry means that it is a scalene triangle. One line of symmetry means that it is an isosceles triangle. And three lines of symmetry means that you have an equilateral triangle. But what about two lines of symmetry? If you have two lines of symmetry, then is there any triangle possible? Well, the answer is no. You have only these three options possible. That is no for scalene, one line of symmetry for an isosceles triangle, and three lines of symmetry for an equilateral triangle. You cannot get any triangle which has two lines of symmetry.